Hey everybody, welcome to lesson 2 of unit 8. We're talking about arithmetic sequences this time. Arithmetic sequences are when the difference between each consecutive term is the same. They call that a common difference. Basically, we're just adding or subtracting the same value every time. Arithmetic, add, kind of makes sense, right? So, these problems, these first ones that we're going to look at, they're going to ask us what is the common difference for each of these sequences. So difference is usually subtraction. So I'm going to work backwards. If I take 18 and I subtract the term prior to it, we end up with 5. That is the common difference, but I'm going to make sure that that's true for each of these. Right? So 13 minus 8, we get 5. 8 minus 3, we get 5. So in between each of these numbers, every time I was adding 5, right? I did 3 plus 5, 8 plus 5, 13 plus 5. So our common difference, which we're going to write as D, equals 5. Let's take a look at this next one. Again, I'm going to work backwards with this. Negative 13, we're going to subtract negative 6, double subtraction, so negative 13 plus 6 is negative 7. So as long as I get that same difference in between each of these, that would be our common difference. So I just check. And we end up getting negative 7 for each of these. So we would say that D, our common difference, is negative 7. Right? And it makes sense because each time I'm subtracting 7. So you try. You're going to find the common difference for each of these sequences. Pause the video and resume when you're ready to check. Alright, let's see what you came up with. 3.9, I'm going to subtract 3.0. We end up with 0.9, right? 0.9. And then if we do that for each of these terms, 3.0 minus 2.1, we get 0.9. 2.1 minus 1.2, again we get 0.9. So here our common difference is 0.9. I'm adding 0.9 as we go along. Again, we work backwards. 51 minus 71, that's negative 20. 71 minus 91, negative 20. 91 minus 111, all of these common differences is minus 20, right? And you can see that we're subtracting as we go along. Okay? Then we have some of these problems down below that are telling us to write the first 4 terms and to find the common difference. So we got to figure out the terms and then figure out what's different between all of them. Okay? So let's see. For our first term, we'd have 1 plus 2 divided by 3, so that would be 3 over 3, which is 1. Second term, we have 2 plus 2 over 3, so 4 over 3, which is 4 over 3. That's not simplifying. Then we have 3 plus 2 over 3, which is 5 over 3. That's also not going to simplify. And finally, our fourth one, 4 plus 2 over 3 is 6 over 3, which is 2. Now, these are the first 4 terms that they were looking for. 1, 4 over 3, 5 over 3, and 2. But they also asked us for the common difference. And I think it's easier to see it here, right? If we do 6 over 3 minus 5 over 3, that's 1/3. We can also see that we're improving by 1/3 each time. So there we go. There's our common difference. Let's take a look at this next example, right? We're still doing the first 4 terms. So let's see, negative 2 plus 3 would be 1. Negative 4 plus 3 would be negative 1. Negative 6 plus 3 is negative 3. And our final one here, negative 8 plus 3 is negative 5. So here's our first four terms. And as far as our common difference, negative 5 minus negative 3, so that's a double negative. So negative 5 plus 3, we get minus 2. And that's really easy to see, right? 1 minus 2 is negative 1, minus another 2 is negative 3. So that's our common difference. So far, not bad, right? You're going to try out some of these on your own. You're going to write the first four terms and then find the common difference. So pause the video and resume when you're ready to check those two. All right, let's see. So your first term, you're going to end up with 3. Second term, we get 7. Next term, we get 11. And our fourth term, we end up with 15. So here's our first four terms, 3, 7, 11, and 15. Then we want to know, then we want to know the common difference. 15 minus 11, that's a common difference of 4. So I'm adding 4 to each term. That looks like it makes sense. Let's check out this next one. Oh, this one's a little bit more intense with the work here, huh? We end up with negative 2 over 5 for our first term. Negative 4 over 5 for our second term. Negative 6 over 5. Oops, that's a 5. And negative 8 over 5. So here are our first few terms. Hopefully you got these, negative 2, 4, 6, and negative 8 all over 5. And the common difference, well, negative 8 over 5 minus negative, so that's double negative, that's adding. So negative 8 plus 6, that would be negative 2 over 5. So that's your common difference. By the way, if at any point with any of these you need to do the subtraction on the side, go for it. There's no reason not to. Okay. Next couple of questions that we see here, they're asking, is the sequence arithmetic? Well, remember what we did the first couple of problems where we find the common difference in between each term? We're doing the same thing. But what we're checking is to see if it's the same number in between each time. Make sense? So let's start backwards like usual, right? 12 minus negative 10, that's negative 2. So our difference here is negative 2. I need to hope that that's the same amount in between each. Right? So negative 10 plus 7 is negative 3. I don't have to go any further. This is not the same difference between the numbers. Right? And if I were to even check, this is going to be negative 4 in between. So we're not adding or subtracting the same amount. So this can't be arithmetic. It doesn't fit the definition. Let's check out this one. Again, we go backwards. 7 over 4 minus 5 over 4. That's 2 over 4, which is 1/2. So if I end up with 1/2 each time, then we're in good shape. Right? 5 over 4 minus 3 over 4. We got 1/2 again. And last, 3 over 4 minus 1 over 4. That's also 1/2. So in between each of these, and it's telling us that it's going to continue in that fashion, it seems like we're getting positive 1/2 every time. That matches the definition of arithmetic. Okay, so you've got 2 to try down here on your own. You can pause the video and resume when you're ready to check. Alright, let's check these out. Again, working backwards here. 7.0 minus 5.6. That's a difference of 1.4. We're hoping to get that in between each. So far, so good. And our last difference, we come up with the same, adding 1.4. So because we're adding the same amount throughout, yes, this is arithmetic. The second one that you need to try right here, the difference between these, we get 5. Difference between these, we get 7. We don't have to go any further. These do not match. That means we're not adding the same amount in between each, so it's not arithmetic. Pretty easy so far, right? Now we're going to work on what's called the nth term formula, because sometimes we want to know what that next term would be. And because we're adding the same amount every time, we should be able to figure out exactly what that number should be. It's pretty easy to do, in fact. Here's what we have. The nth term formula tells us that whatever our nth term is, we're going to take our very first term, so we have to know at least the first one, and we're going to add to it whatever the position is, minus 1, times the common difference. Okay, so this is our formula. And as we start doing these, this formula really makes sense as to why, right? It's because we're starting with our first thing and we're adding so many of those common differences to it. So once we start doing this, you're going to see, okay, this formula makes sense. Okay, so here's how it works. They want us to find the formula for the nth term of the arithmetic sequence, so we know we're going to be using a common difference, and they give us the common difference as -4, and they give us the first term as -8. Remember, we needed that first term. Okay, so what we've got to do is we've got to figure out what the common difference is. Right, that's the very most important thing, and they actually give that to us. So we're going to start plugging in some values here, right? And a sub 1, they told us our first term is -8. And our common difference they give us as -4. If we distribute, because this is multiplication, that gives us -4n and +4. If I combine like terms, that -8 and that +4, here's what we get. -4n minus 4. So this is the formula. So if you want to know, let's say, the fifth term, if we do -4 times 5 minus 4, that would give us the fifth term's value. Pretty cool. So you're going to try this on your own. Basically, you're plugging in the values into this formula. So pause the video and resume when you're ready to check. Alright, let's see. We want to be doing a sub 1 first, so the first term, which is -5, times our common difference, which is 13. We have to distribute into both. So let's see, that'd be plus 13n minus 13. If I combine like terms, we get 13n minus 18. So if we wanted to find the next term in this sequence, like let's say if we wanted to find the 100th term, we would do 13 times 100 minus 18, and we get that number. It's kind of cool. We can figure out any term anywhere that we want now. Okay, so here's another one. They want us to find the 20th term of the arithmetic sequence, but this time they're not giving us a common difference, and they're giving us some random points. Actually, they're not giving us random points, they're giving us consecutive points, which is good, because if this is arithmetic and these are the two terms in a row, we can find the common difference by subtracting our term minus the previous term. So we found a common difference of 6. Now we can plug into the formula we were using before. Right? We know our first term is 3. And we just found our common difference is 6. So even though they didn't give it to us in this problem, we knew, because they were consecutive, that we could find it. So we have to distribute. If we combine like terms, our equation is going to be 6n minus 3. That's our formula. But they want us to find the 20th term. So here's what we're going to do. I'm going to plug in 20 into this formula. So it's going to be 6 times 20 minus 3. 6 times 20 is 120. Minus 3 would be 117. So the 20th term is 117. Pretty cool. So you're going to try this one. You're going to find the 38th term of the arithmetic sequence that starts with 4, then negative 3. Pause the video and resume when you're ready to check. All right. So we need to figure out the actual formula first, and we need to figure out the common difference, right? Let's find the common difference first. We're going to take our second term, and we're going to subtract our first term, and we get a common difference of negative 7. Let's see. The formula says our first term plus n minus 1 times the common difference, which is negative 7. So we've got to distribute. So let's see, 4 minus 7n plus 7. So our formula is negative 7n plus 11. We want to know the 38th term. So we've got to do negative 7 times 38 plus 11. Oh, let's see. 38 times 7. Let's see. That's 56, 21, 26. But that's negative. If we add 11, that's going to give us negative 255. Okay. So, slightly different problem that we're looking at now, okay? Because they want us to find the 5th and 8th terms, okay, and that's not a big deal, of this arithmetic sequence. But they're not giving us the first term, and they didn't give us the next term. They gave us A9. So there's a lot of stuff missing here. But here's what we're going to do, okay? To find the common difference, we're going to find the difference between these terms, like we would usually do. But the thing is that the distance between these, we're going to have to kind of chop up whatever this is into the average distance. And seeing as I have the 9th term here and the 3rd term here, I know that I would be cutting it up. Oops, I wrote the answer. I know I'm going to be cutting it up into 9 minus 3 pieces, right? If you can imagine like a number line with all these digits, there should be so many spaces in between the 3rd and the 9th, and it's going to be going up by so much. So this little fraction right here, the difference between the digits that they give us and the difference between the placement, we can actually calculate the average common difference. Right? If you do 41 minus 17, that's 24. 9 minus 3 is 6. So our common difference, we end up getting a difference of 4. But we still have the problem of the fact that they want the 5th term, and we didn't give us the first term. And if you remember, the formula we used up here, it required our first term. So we're going to have to kind of cheat a little bit. We know our common difference is 4, so if I'm starting at the third position, which is 17, if I want the fourth position, I'm going to have to add 4, right? Because that's what it tells us to do. So a sub 4 is going to be 21. And I'm going to have to do another add 4 to get a 5. So let's see, 21 plus 4, 25. We want the 8th term. If they give us the 9th, well, we know that the 8th should be one digit before it, and I've been adding 4 going up, so going backwards would be subtracting 4. So if I took my 9th term and I went backwards to get my 8th term, I would be subtracting 4. So 41 minus 4, that's 37. So those are the 5th and 8th terms. So real quick recap, because you're going to try one down here. We found the common difference by taking the difference between these two numbers and the distance between those two numbers. And that gave us the average common difference. And then we kind of had to cheat a little bit. We either added or subtracted depending on which direction our common difference. So you're going to try this one out down here. I'll leave this one up in case you need to look at it. Pause the video and resume when you're ready to check. All right, so they give us the 2nd and 12th terms. So we're going to have to find the distance between these and the distance between their positions. So let's see, that gives us 120 over 10. So the common difference here is 12. So basically we're adding 12 to get to the next digit or subtracting 12 to get previous numbers. Right, so if I want the 7th one and I have our 2nd, I need to be adding 12, right? So if I add 12, that gives me 11 for the next one. If we add 12, that'll give us 23. If we add 12, that'll give us 35. If we add 12, it'll be 47. 59. So we finally get our 7th term, which is 59. Well, let's see, we could probably just, well, if we're at A12 is 119. If I subtract 12, that'll get us A11 at 107. And if we subtract 12 again, that'll give us our A10 term, which is what we're looking for. So minus 13, that would be 95. So our 7th and 10th terms are 59 and 95. Hopefully that wasn't too difficult and you got those solutions. Really the common difference is probably the most trickiest, and then just either adding or subtracting to get to where you're looking for. Now we're going to look at something a little bit different, which is called the nth partial sum. And I've got a quick little story about this. You can check up on the internet, and I'm sure people can probably comment on it. But there's a famous mathematician named Carl Gauss, who is really the big shot name for nth partial sum. And the reason why is because there's a story of when he was a little kid, the teachers basically ran out of material to teach the kid because he was so good at math. His teachers didn't know what else to teach him. So they would just give him busy work, and they'd be like, here, do this, whatever, do this, to keep him busy. So one day, I was like I don't know, somewhere around like a 3rd grade age or maybe even younger, the teachers were trying to keep him busy, and they said, all right, Carl, add up every number from 1 to 100. And they figured that would have kept them busy for a couple of minutes, right? But Carl, being as good as he was at this, he like looked for maybe a second or so into the air, and then he was like, here's your answer. And the teachers were just baffled because that was the correct answer, and he got it way faster than he was supposed to. It was supposed to take up some time. But he knew exactly what was going on. Right? He started thinking about the pattern in his head. He knew that if he was to add the first and the last number together, then he would get some number. And if he was to take the second number and the second to last and add those, he'd end up with that same number. So basically, he's going to get some number, and he's going to be multiplying it by so many times. Right, so he figured this out basically in his head. He figured out how this nth partial sum formula worked, right? Which is really cool because he was trying to be kept busy, and they failed pretty miserably at it. I think that's funny. Anyways, so here's what's going on. For the nth partial sum, right? Remember, we're adding everything in a arithmetic sequence. So we need to know however many we're adding together. We need to know the first number and the last number, and we're going to divide by 2. So we need to figure out the nth value in order to do any of this. Okay, so that, for example, right, we want to find the nth partial sum for each arithmetic sequence. Here they're giving us 2, 5, 8, so on and so forth, and we want to add all of the first 18 terms. So first of all, we're going to need to find a common difference. Our common difference here is going to end up being 3. Okay, but then we also need to know what the nth term is, right? The 80th term, right? The last one, so the 18th term. In order to do that, though, we need to know what that formula looks like. So I know my first term, and we just found our common difference. If we distribute and combine like terms, we end up with a sub n being 3n minus 1, which is good because all we have to do now is plug in the 18th term, and then we can plug it into this formula. So if we were to do 3 times 18 minus 1, we end up with 53 for the 18th term. Okay, so now we have the first term, we have the last term, and we know how many things we're adding together. We're adding together 18 of them. So we're going to plug into this formula. We're going to do 18 times 2 plus our 18th term, which is 53, divided by 2. Okay, well, let's see. 2 and 18, we can reduce that to 9. So we've got 9 times 2 plus 53 would be 55. So we've got 9 times 55, which is 495. So I don't know if little Carl Gauss would have gotten that faster than we just did on the computer. He probably would have. But we've got one more as an example, so if that didn't click right away, we've got another one to look at. Okay, we're going to do the same thing. We've got to find our common difference. Let's see. Our common difference here should be -8. Now we've got to figure out our nth term formula. So our first term times our common difference. So let's see, we get -8n plus 31. They want us to find the 30th term. Let's see, -8 times 30 plus 31. That's going to end up being -209. So that's the 30th term. We need the first, the 30th, and however many we're adding. So let's see, that would be 30 times 23 plus negative 209 divided by 2. Let's see, this 2 and 30, that's going to reduce. So we've got 15 times, let's see, negative 209 plus 23, that's negative 186. And let's see, 15 times negative 186. That's going to be negative 2,790. Okay, so we've done 2 examples of nth partial sum. So you're going to try these 2 out on your own. Pause the video and resume when you're ready to check your solutions. All right, let's see. First thing, we got to find that common difference. So I'm coming up with a common difference here. 92 minus 108, that's going to be negative 16. Then we got to find the nth term. So let's see, 108. Distribute, so let's see. Negative 16n plus 124. So that's the nth term formula. We need to figure out the 13th term. So a sub 13 let's see, negative 16 times 3 plus 124, that's going to end up being negative 84. If you needed to use a calculator for that, or if you did your work on the side, whatever. Right? We just needed that term. Now we can plug it into this formula. We're finding the 13th. So we got 13 times 108 plus negative 84 divided by 2. So I can't divide by 2 here, so we'll have to wait a minute for that. 108 minus 84, that's 24. This we can actually simplify, right? So that's going to go become 12. So we've got 13 times 12. 13 times 12 is 156. So hopefully you came up with a 156 as answer for A. Let's check out what you got for B. Finding our common difference here, let's see, I'm going to do 11 minus 4, which is 7. So our common difference is 7. We've got to find that nth term. So let's see, our first term is negative 3. Distribute. So our formula is going to be 7n minus 10. We want, whoa, the 100th term. So we're doing 7 times 100 minus 10. So we end up getting 690. So we need the first term, the 100th term, and plug them in. So let's see, it's going to be 100 times negative 3 plus 690, oops, divided by 2. That 100 is going to become a 50, thanks to dividing by 2, times, let's see, that would be 687. So we've got to do 50 times 687. Probably be faster on a calculator, but do it however you need to. You're going to come up with 34,350. Okay, so that's it for arithmetic sequences. Pretty easy stuff. It's a lot of stuff. Obviously, we're at 35 minutes into this video, but we're done now. So if you have any questions, I would suggest to bring them with you to class, or you can leave them on the comments, and maybe somebody out there in the world will answer it for you. That's really it for arithmetic sequences. We're going to look at geometric next time, so see you there.